Welcome to physicsnp.com. We have MCQs on gravitational force for today. There are 30 questions that we will discuss today here. The first question is on the screen. The dimensions of universal gravitational constant are. So for that, we will use the formula for gravitational force G m1 m2 by r square, which gives z is equal to f into r square by m1 into m2, keeping the dimensions of all the terms m lt minus 2 for the force, l2 for square of the radius, so distance, and m into m for the mass. Solving all, we get m to the power minus 1, L power 3, T power minus 2. So this is the gravitational constant, dimensions of gravitational constant. So the correct answer is A. Now question number 2. If the radius of Earth shrinks by 1% when its mass remains constant, the value of z on its surface would be A, B, C, D. Increases by 1%, decreases by 1%, increases by 2%, decreases by 2%. So for this, we will again take the formula for value of z. Z is equal to Gm by r square. Now using the concept of uh, differentiation for the fractional change, we have change in value of g by original value of g is equal to minus 2 times change in value of r by value of r. So since as given in question, the radius shrinks by 1%, so del r by r will be equal to minus 1%. As said in question, radius shrinks, so minus by 1%. This represents minus, and therefore del g by z will be equal to minus 2 into minus 1, that is 2%, which is a positive value, so increases by 2%. So the correct answer is C. Question number 3. The escape velocity of a body from Earth depends on mass of the body, angle of projection, mass of the Earth, both A and C. So for this, we will consider the formula for escape velocity. This is given by BE is equal to root under 2gm by r. So as you can see, that mass of the body is not available in the formula, angular projection is not available in the formula, yeah, but mass of the earth, m, mass of the earth is available, so that means it depends on the mass of the earth. Question number 4. At what height above the earth's surface does the acceleration due to gravity becomes 1/4 of the value of the surface on the earth? So variation of z due to the height is given by g at the surface into r by r plus h whole square, where h is the height. Now as said in the question, according to question, the at height h, the g is 1/4 of g. So keeping this value, 1/4 g is equal to g r by r plus h whole square. G cancel. 1/4 is equal to r by r plus h whole square. So this gives 1/2 is equal to r by r plus h. So r plus h is equal to 2r, and finally h is equal to 2r minus r, Therefore h is equal to r. So this means uh, at height equal to radius, that means this is the earth, this is the radius of the earth, and to a point above the earth at a distance again r. At this point, the acceleration due to gravity will be 1 by 4th of the acceleration due to gravity on earth. So our correct answer is A. Question number 5. The value of z at the center of the earth is. So this is a basic question, that at the center of the earth, this is earth, the value of g on the surface is g is equal to 9.8 meter per second square, and going above g decreases, going below also g decreases, and at the center g is equal to 0. If you remember, it is okay, or otherwise you can use the formula for the acceleration due to gravity inside the earth. G in depth is equal to g times 1 minus d by r. D represents depth. So at the center d will be equal to r. So therefore g at the depth will be equal to g times 1 minus r by r, that is g times 1 minus 1, that is 0. So that means at the center of the earth acceleration due to gravity is 0. The correct option is C. Next question, question number 6. Kepler's second law is a consequence of the conservation of linear momentum, angular momentum, energy and mass. So this is a conceptual question. Here, first let us show the second law, Kepler's second law. What it states, that if this is the sun and this is a planet revolving around the sun, let here be the sun, and this is any planet, for example earth. So Kepler's second law states that the area covered by the this line in equal interval t1, say t, and similarly over here, if these two areas are covered in the same time, then both the area will be equal according to Kepler's second law. And by theoretical concept, this law is total consequence of conservation of angular momentum, which states that the object rotational momentum always remains constant unless any force, external force, acts on it. So the correct answer is B. Now question number 7. The relation between escape velocity and orbital velocity for a satellite close to Earth is. So for this, first we need to write the formula for escape velocity. Escape velocity is given by 2gm by r, and orbital velocity for a satellite is given by gm by r, and you can see from the concept b is equal to 2 times bo. So the correct answer is B. Question number 8. A geostationary satellite has a period of. This is a conceptual question. A geostationary satellite is what that remains always at the same point when observed from the Earth. This is only possible when the Earth rotation and the satellite revolution have same time period, and then only the Earth then only the satellite will be at the same position all day. This is only possible when Earth and satellite had same time period, that is 24 hour. Next question, the gravitational potential energy of a body of mass m at a distance r from the uh, center of earth is. So this is just a formula. Gravitational potential energy is minus g m by r. So the correct answer is B. The value of g is maximum at. So we know that g is proportional to 1 by r square, and obviously uh, r is small at pole because of the oval shape. So that means g is more at pole, that is g is maximum at pole. Question number 11. If earth stops rotating about its axis, the value of g will be. So the variation of g due to rotation of earth is given by g minus r omega square cos square phi, where phi is the latitude. So if the earth stops rotating about, the value of g at the equator would be. So at equator we must know that latitude is 0. So z dash will be equal to z minus r omega square. And if the earth stops rotating, then omega will be equal to 0. So in that case, g dash will be equal to g. That means uh, initially, due to rotation, the g was less because of the subtraction term. But when the rotation stops, it becomes equal to g. That means here, due to rotation, after stopping the rotation, the acceleration due to gravity increase. So the option is A. Question number 12. Two pairs of masses m and m are situated in air uh, and the gravitational force between them is F. If the space is filled with a liquid of density rho, the force will be. So one thing that we must know, that it is a gravitational force. Gravitational force is independent of the medium, whether whether there is any medium between two masses m1 and m2, any medium, the gravitational force remains same because it does not depend upon the medium. So the force will be again F. Correct option is A. Question number 13. The escape velocity of a planet with twice the radius and same as Earth, same density as Earth is. So we know that the escape velocity of Earth is 11.2 kilometer per second. Now we are talking about a new planet where radius is double and density is same. So first we will convert the escape velocity formula 2gm by r uh, in the term of density. 2g mass is equal to volume into density by r. So this comes out to be 8 by 3 pi g density into r. So we can see that escape velocity is proportional to r, as the bracket term is a constant. So if radius is doubled, escape velocity also double. So the correct answer is 22.4 kilometer per second. Next question. A body of weight 72 Newton on Earth's surface is taken to a height equal to half the radius of the Earth. So this is Earth. The weight at this point was 72 Newton. Now it is taken to a point where the height is equal to r by 2. In that case, what will be the weight over here? New weight. So we know that g dash is equal to g times r by r plus h whole square, and mg dash is equal to mg times r by r plus h whole square, or new weight is equal to old weight at surface into r plus r square. Now putting the value of height r by 2, half the radius of the earth, and solving, we get r by 3r by 2 square, or 2 by 3 square. So 72 into 4 by 9, which gives 42 Newton. So the correct answer is B. Now question number 15. The period of a satellite in a circular orbit of radius r is t. The period of another satellite in radius 4r. So this is Earth, and one satellite is over here at a distance r. Another satellite is here at a distance 4r. So we need to calculate the relation between time period of these two satellites. So we know that the time square of the time period is proportional to r cube, or t is proportional to r to the power 3 by 2. So time period of second by time period of first is equal to r2 by r1 power 3 by 2. This is equal to 4r by r power 3 by 2 is equal to 4 power 3 by 2, that is 8. So T2 is 8 times T1, that is correct answer is B. Question number 16. If the distance between two masses is doubled, the gravitational force is inversely proportional to square of distance. So if the distance is doubled, that means uh, so force will be also proportional to 1 by square of the distance, and in that case F2 by F1 is proportional to T1 by D2 square. Now as we know that equal to D1, D2 is 2 times D1, so this will equal to 1 by 4, or F2 is 1 by 4 times F1, that means force decreases by 1 by 4 time. Correct option is B. Question number 17. The gravitational intensity inside a hollow spherical shell of uniform density. So inside a hollow sphere, since there is no mass, and hence intensity is 0. Question number 18. Weight of a body at depth d is equal to weight of at height h. If both are small, then what may be the relation? So at depth, the formula for acceleration due to gravity is this, and at a height h, the formula is 1 minus 2h by r for a short distance. Now, since GD and GH are equal, we will equalize these two equations and solve. We get D is equal to 2H. So the answer is B. Question number 19. Work done in moving a mass m from Earth's surface to infinity. So work done to move a mass from the surface to infinity is the gravitational potential energy, which is equal to work done mgr. Or by the concept of formula, you can calculate that at infinity the gravitational potential energy is 0, and at this point the gravitational potential energy is minus gmm by r, and work done to bring from here is the difference between these two terms. That means W is equal to potential energy at infinity minus potential energy at surface. So at infinity 0 and minus gmm by r, this gives gmm by r, and gm is gr square. So finally mgr is the relation. Answer is B. Question number 20. For a satellite, the ratio of kinetic energy to total energy. So kinetic energy of satellite is gmm by 2r. Potential energy is minus gmm by r. Total energy is sum of kinetic plus potential, which is equal to minus 2 gm minus gmm by 2r. So ratio of kinetic to total energy will be equal to gm by 2r by minus gm by 2r, that is 1 by minus 1. So answer is B. Question number 21. The orbital speed of a satellite. The orbital speed of a satellite depends on mass, mass of the satellite, radius of orbit, both can be none. So for this we write the formula of orbital speed as gm by r. This is Earth, this is mass of the Earth, and at a distance small r there is a satellite which is revolving, and its orbital speed is given by this formula. So you can see that mass of satellite is absent, radius of orbit is present there. That means the correct option is B. Question number 22. The period of a simple pendulum at the center of the earth is. So at center of earth, g is equal to 0. So time period of simple pendulum 2 pi root under L by g will be infinite. That means the pendulum will be at rest. Question number 23. If a body is taken from equator to pole, its weight. So as we know that g is proportional to 1 by r square, or we can say weight is proportional to 1 by r square. At pole, less r, more weight. At equator, more r, less weight. So while going from equator to pole, you are going from less weight to more weight. That means the weight is increasing. Question number 24. Two satellites move in orbits of radius r1 and r2. Their orbital speed v1 and v2 satisfy. Two satellites move in orbits of radius r1 and r2. So this is Earth. One satellite is at radius r1. Another satellite is at radius r2. And we need to compare the orbital speed. So we know that orbital speed is gm by r1 for the first satellite and gm by r2 for the second satellite. Dividing, we get r1. So the correct option is C. Question number 24. The binding energy of a satellite of mass m in an orbit of r. So the binding energy is the total energy, negative of total energy, and we know that total energy is again negative gmm by 2r. So cmm by 2r is the binding energy of satellite. Option is A. Question number 26. If Earth rotation speed increases, the value of g at the equator. If Earth's rotation speed increases, the value of g at the equator will be. So, variation of g with respect to rotation is given by g minus r omega square cos phi, where phi is the latitude. So, at equator, phi is 0. So, variation change in g, the new g is equal to g at surface minus r omega square. So if omega increases, more g decreases. That means g dash decreases. So correct option is B. 27. Gravitational field is a conservative field, non-conservative field. So this is a thing of concept that when a mass move between two initial and final positions, in that case, if the initial and final position is same, then the work done due to gravitational force is 0, so it is a conservative force. Question number 28. The weight of a body in a freely falling lift is. So in case of free falling lift, the apparent weight will be m times will be mg minus ma. During free fall, the acceleration is equal to g and the weight will be equal to 0. Question number 29. If the distance of the earth from sun becomes half, the duration of year will be. So as we know that the square of time period of rotation of the satellite or planet around the sun is proportional to r cube, or t is proportional to r power 3 by 2. So in that case, t2 by t1 will be will be equal to r2 by r1 power 3 by 2. As said in the question, the distance becomes half. That means r2 r2 is equal to r1 by 2. So r1 by 2 by r1 power 3 by 2. This gives 1 by 2 power 3 by 2. And this is 1 by 2 root 2 T1. So the correct option is C. Last question, question number 30. Gravity is responsible for which of the following? A retention of atmosphere, tides in the ocean, motion of planets. So gravity plays a key role for all the three. For the atmosphere, it provides required centripetal force that holds the molecule inside the planets nearby. So this is also retention of atmosphere is for retention of atmosphere. Gravity is also responsible. Similarly, because of gravitational pull from the moon, the tides occur on the ocean. So in ocean, for tides in ocean, gravity is responsible. Similarly, uh, for the rotation of the planet, it must have a centripetal force for rotation, and that centripetal force provided by the heavenly body which is at the center of the path. For example, for Earth, the rotation is possible due to centripetal force, and centripetal force is given by the attraction between sun and earth. So motion of planet is also gravity is also responsible for motion of planets. So that means all of the above. These 30 questions are equally important for your entrance as well as for grade 12 MCQs. So this much for today. Thank you everyone.